Hi, this is a lecture on linear transformation. In this lecture, we are going to discuss on matrices and linear transformations. So, how we can define matrix representation of a linear transformation. So, topic is how we can define matrix representation of a linear transformation. So, let VF and WF be two vector spaces of dimension n and m respectively. So let B equal to x1, set x1, x2, x3, xn, and B dash is equal to y1, y2, y3, ym, be their order basis respectively. Suppose E is a mapping from vector space V over the field F to W. See again a vector space over the same field F. And this be a linear transformation. This be a linear transformation. Then EX1, EX2, EX3, and so on, EXN. This belongs to, so we take x1 from V, and the image of x1, that is tx1, this belongs to W. Similarly, tx2 also belongs to W, tx3 also belongs to W, and txn belongs to W. And linear span of B dash, that is equal to W. Therefore, we take let tx1, because linear span of B dash is equal to W and tx1 belongs to W. So every element of W can be expressed as a basis of B dash. And what are the bases of B dash? What are the bases? B dash, that is y1, y2, y3, yn. And they are the elements of W. They are the bases of W, right? So tx1 can be represented in terms of y1, y2, y3, and yn. So we can write tx1 as a11 y1 plus a21 y2 plus a31 y3 plus am1 yn, because y1, y2, ym are the bases of W, and because linear span of B dash, that is equal to W, so every element of W can be expressed as a linear combination of its bases. Similarly, we can write tx2 as a12 y1, a22 y2, a32 y3 plus am2 ym. So px3 is equal to a13 y1 a23 y2 plus a33 y3. So am3 y1. So how we can write, if this is a this is the representation of tx1 tx2 tx3, how we can write txj, or we can write uh, exn. exn is equal to a1n y1 a2n y2 a3n y3. So what is the last element? This is amn yn. So where the coefficient aij, what are the coefficient? They belongs to field, right? So for given any I belongs to 1 to m and j belongs to 1 to up to so on n, aij such that aij belongs to field. That is, if we, how we can write txj. Now how we can write txj? So if txj lies here, j is any element, j is any element between 1 to n. So how we can write txj? That is a1j a1j y1 plus a2j y2 plus a3j y3 plus amj y. So this is the representation of txj. So how can we write this? This is equal to summation I is equal to 1 to m aij yj, right? Even we can write this as txj. So for all, here we can say given any, that is given any j belongs to 1 to up to n, such that txj is equal to this. So txj is represent as a linear combination of the basis of w, that is b dash. So then the matrix m cross n of order, matrix of order m cross n is represented by a, is noted by a, and is, what is a? It is a11 a11 a12 a13 and a1n, a21 a22 a23 a2n, a31 a32 a33 and a3n, and similarly am1 am2 am3 and amn. So this is the matrix of order m cross n. So how we can represent this? This is the coefficient of these. So A11, A21, A31, AM1, A12, A22. So we take the coefficient matrix of y1, y2, yn, and then we take the transpose. So after taking transpose, what we get? This is the required matrix. So this is called matrix of T. This is A is called the matrix of T with respect to order basis B and B dash, and is noted by T with basis B and B dash. Or simply we can write this as matrix T. So in particular, if W is equal to V, if V is equal to W, okay? If W is equal to V, B dash and B dash equal to V, then the matrix of T with respect to the order basis B is denoted by TB. So let us discuss one example. So here we discuss example number 1. Find the matrix representation of T with respect to the order basis B, where T is a mapping from R2 to R2 defined as Txy equal to 3x minus 4y, x plus 5y, and the set of bases B equal to 1, 0, 0, 1. These are the usual bases. Okay? So we have to find the associated matrix related to this transformation T. Now in second, T is a mapping defined from R3 to R3 defined as Txyz equal to x plus 3y, 2z minus 5, x plus z. And the bases are 1, 1, 1, 1, 1, 0, 1, 0, 1. So we first discuss first example. So given what is the given transformation? Given that E is a mapping from R2 to R2. This is defined by Txy is equal to Tx minus 4y, x plus 5y. And the bases are set of bases B equal to usual bases 1, 0 and 0, 1. And we know that if the usual bases are given, even bases are given, then we can write any vector in R2 as a linear combination of bases, elements of bases. So if we take given any AB in R2, so AB can be represented, we can write AB as then there exists alpha beta in field, let it be field to be set of real number. So we can write alpha beta belongs to R such that AB is represent as alpha time 1 0 plus beta time 0 1. That is alpha 0 plus 0 beta. And how we can add alpha 0 0 beta, that is we get alpha plus 0 and 0 plus beta, that is alpha beta. So we get AB is equal to alpha beta, and two order pairs are equal if and only if A equal to alpha and B equal to beta. So here we get alpha equal to A and beta equal to B. So if this is our first equation, so any element AB in R2 can be written in term of A into 1 0 plus B into 0 1. So if you give me any element of R2, I can write this as a linear combination of the elements of basis. So now, what is the transformation Txy? It is already given. So what is the output of T10? This 10 is the basis. It is given. So image of T10, that is equal to, this is we put the value x equal to 1 and y equal to 0. So we get 3 minus 0, 3, 1 plus 0, this is 1. So we get 3 comma 1. So this is 3 comma 1. And any element AB can be written as a linear combination of elements of basis. So we use 2. Here A is equal to 3 and B equal to 1. We can write 3 into 1 0 plus 1 into 0 1. Now, what is the output of T01? T01 is, we put x equal to 0 and y equal to 1. So we get 3 minus 4, 0 minus 4, minus 4, and 0 plus 5, 5. So minus 4 comma 5. So we get minus 4 comma 5. And now again, using 2, we can write AB as A into 1 0 plus B into 0 1. And here A is minus 4 and B is 1. So we can write minus 4 into 1 0 plus 5 into 0 1. Now, the matrix, therefore, the matrix T associated with basis B is 3, 1, minus 4, 5. We take the transpose, right? So we can write even dash or we can write T. T for transpose. That is 3 minus 4, 1, 5. So this is the associated matrix with respect to basis. Go through this example once again, and if you have any doubt, then pause the video, revise it, and then you proceed. Now, second one. T is a mapping. It is given that T is a mapping from R3 to R3. It is defined as Tx by z equal to x plus 3y to z minus y x plus z. But here bases are not usual bases, right? So bases are 1 1 1 1 1 0 1 0 1. So given that the transformation T is defined as Txyz is x plus 3y 2z minus y and x plus z. Okay? And set of bases B equal to, we can write 1 1 1, 1 1 0 and 1 0 1. So now given any ABC in R3, there exists alpha beta gamma belongs to field, let it be R, such that any element A, B, C can be represented as a linear combination of bases, elements of bases. And alpha into 111 plus beta into 110 plus gamma into 101. So we can write this as alpha plus beta plus gamma, alpha plus beta and alpha plus gamma. So if we compare, two order pairs are equal if and only if alpha plus beta plus gamma equal to A, alpha plus beta equal to B, and alpha plus gamma equal to C. So if we put alpha plus beta to be B here in equation, if this be 1, this be 2, and this be 3. So if we put alpha plus beta equal to B, so we get gamma equal to A minus B, right? And if we put alpha plus gamma equal to C in equation 1, alpha plus gamma to be C, then we get beta equal to A minus C. Now you put beta equal to A minus C in second, then we get alpha. So alpha is equal to B minus A plus C. Okay? Or we can write alpha equal to minus A plus B plus C. So put all these values in equation star, then we get ABC can be written as ABC can be written as alpha minus A plus B plus C into 1, 1, 1 plus beta A minus C into 1, 1, 0 plus gamma A minus B into 1, 0, 1. So if you give any element, any vector in R3, then we can represent that vector as a linear combination of its bases. Right? So now, what are the elements of basis B? That is 1, 1, 1. So we find the output of 1, 1, 1. So T of 1, 1, 1. T of 1, 1, 1. We use the transformation and we get T of, if we put x equal to 1, y equal to 1, z equal to 1, then we get 1 plus 3, it is 4. 2 minus 1 is 1. 1 plus 1 is 2. So 4, 1, 2. So we get 4, 1, 2. And now using, let this be equation 4. So using 4, here A equal to 4, B equal to 1, C equal to 2. So we can write minus 4 plus 1 plus 2. So minus 1 into 1, 1, 1 plus A minus C. 4 minus 2, it is 2 into 1, 1, 0. And plus A minus B, 4 minus 1 is 3, 1, 0, 1. So any element 4, 1, 2, the output of T11, that is 4, 1, 2, and it can be written as a linear combination of the element of basis. So even we can say by using 4. Now similarly we can write T110, and by using the transformation we get it is 4 minus 1, 1, and we can write this as 4 into 4 A is minus 4, A is 4, so minus 4 minus 1 minus 5 plus 1, so it is minus 4. So we can write minus 4 into 1 comma 1 comma 1 plus 3, 4 minus 1 is 3, 1, 1, 0 plus A minus B, 4 plus 1, 5, 1, 0, 1. Now T of 1, 0, 1 is 1, comma 2, comma 2. Using the transformation T, we get this. And we can write this as minus A, minus 1 plus 2 plus 2. 2 plus 2, 4, minus 1 is 3. 3 into 1, 1, 1 plus minus 1 into 1, 1, 0 plus minus 1 into 1, 0, 1. So now how we can write the transformation? Transformation P with basis B is equal to coefficient of 1, 1, 1, that is minus 1, 1, 1, 0 is 2, 3, similarly minus 4, 3, 5, 3, minus 1, minus 1. We take the transpose of this and we get minus 1, minus 4, 3, 2, 3, minus 1, 3, 5, minus 1. So this is the associated matrix with respect to the given transformation plan. Now pause the video, revise, and then proceed. So use PRP, take a break of 30 seconds, go through the video once again, revise it, and then we proceed. So now example number 3, let A is a matrix of order 2 cross 2, that is elements of matrix are 5, 3, 1, 2, and T be a linear operator on R2 defined by T of V. If we take any vector V in R2, then we get output is A into V, where V is written as a column vector. Find the matrix of T with respect to the order basis V. Again, we have to find the matrix. So what is given? Given that matrix A is equal to 5, 3, 1, 2, and the basis set B is equal to minus 1, comma 2 and minus 3, comma 4. So these are the bases. So any vector V, uh, if we take any given any V in R2, and what is our V? That is V is equal to x comma y. This belongs to R2. Then T of V, we get T of V means T of x comma y, and we get A into V. It is given. So A into V means 5, 3, 1, 2, and because V is a column matrix, so column vector, so it is x comma y. So we multiply matrix multiplication, we get 5x plus 3y and x plus 2y. So we can write this as a vector. We can write this as a vector 5x plus 2y, 3y, comma x plus 2y. So this is the transformation Pxy is given. So in this way, we can find the transformation Pxy, that is 5x plus 3y, x plus 2y. Now bases are given. So given any AB in R2, we can write there exists alpha beta in R, field R, such that AB can be written as a linear combination of minus 1 bases. What are the bases? Minus 1 comma 2 plus beta times minus 3 comma 4. So we multiply this, we get minus alpha 2 alpha plus minus 3 beta comma 4 beta. We add two vectors, we get minus alpha minus 3 beta comma 2 alpha plus 4 beta. So when we compare two vectors, when we say two vectors are equal, if and only if for each I belongs to 1 to 2, AI equal to, we can say xi equal to yi. Even here we can say A equal to minus 3, minus alpha minus 3 beta, and B equal to 2 alpha plus 4 beta. So we get minus alpha plus 3 beta equal to A, and 2 alpha plus 4 beta equal to B. So after solving this in term of find the value of alpha and beta in term of A and B, we get alpha equal to 4A plus 3B by 2 and beta equal to minus 2A plus B by 2. Or beta to be 2A plus B by 2. Okay. So beta equal to minus time 2A plus B by 2, because here this is minus. So we get alpha equal to 4A plus 3B by 2 and beta equal to minus 2A plus B by 2. So we put alpha and beta in, let this be equation star. So AB, any element AB in R2 can be written as 4A plus 3B by 2 into minus 1 comma 2 plus, even we can write minus 2A plus B by 2 into minus 3 comma 4. So again, this is important because when we use transformation and we get the element in R2, and any element in R2 can be can be written as a linear combination of the elements of basis. So let this be 2. Now we find that transformation of the output of T of minus 1 comma 2. But is by using the transformation we get this is equal to 1 comma 3, and 1 comma 3 can be, how we can get 1 comma 3, we put this here, this is, let this be 1. Okay. So x equal to minus 1 and y equal to 2. Minus 5 plus 6, it is 1. Minus 1 plus 4, it is 3. So we get 1 comma 3. Okay. And 1 comma 3, any element in R2 can be written as 4 1 is 4 plus 3 3 is 9, 13 by 2 into minus 1 comma 2 minus 2 plus 3 5 by 2. So we can write plus minus 5 by 2 into minus 3 comma 4. And similarly T of minus 3 comma 4 can be, the output of this is that is minus 3 comma 5, and this by using 2 we can write this as minus 3 by 2 comma minus 1 comma 2 plus 1 by 2 minus 3 comma 4. And the matrix associated with basis B is 13 by 2 minus 5 by 2 minus 3 by 2 1 by 2 transpose, and this is, we can take 1 by 2 to be common, so 13 minus 3 minus 5, this is that. So this is the required matrix associated with the given transformation. So you can try questions related to these topic. Thank you. Have a nice day.